All right, CNT125, Chapter 8. I'm going to go through a couple subnetting fundamentals, some ground rules on subnetting. We do need to remember our network address. We do need to remember broadcast address and usable. So let's just kind of bring those out again and get some details in here. The network address or network ID, this is the number that gets used to identify the network. And as I like to say, a network like Main Street, Mechanicsburg, PA versus Main Street in Dayton, Ohio. If I say Main Street, Mechanicsburg, PA, there is only one of those on the entire planet. But if I just say Main Street, well, just about every major town has Main Street. But if I'm specific and say Main Street, Mechanicsburg, PA, there is only one of them. But that is not defining any houses on the street. So it's just kind of like the street name. So my network address is identifying the network, the York network of hack, the Gettysburg network of hack, the Harrisburg network of hack. And that would be a specific set of numbers to identify that network. So to do that, the network address, the host portion is set to all zeros. The host octets, the host portions are set to all zeros. So a 95000 would be a Class A network ID. A 135.50.00 would be a Class B network ID. A 195.32.12.0 is a Class C network ID. This is important for two reasons. It identifies the actual network. Again, the Gettysburg network of hack as opposed to the York network of hack. And secondly, this number cannot actually be used for anything. Again, I can't slap this address on a house. I can't just say, the address in this house is Main Street, Mechanicsburg, PA. I can't do that. I need to use a house number, 123 Main Street, Mechanicsburg, PA. So I can't actually assign this number to anything. It's used simply for identifying the network. Routers are going to refer to that to know what network to send things to, but I can't assign that to a printer or a desktop, an IP phone, a server. I can't assign that number to anything. The next number we need to keep in mind is our broadcast address. The broadcast address is the number that we use to send a message to all nodes on the network. Kind of like, hey, does anybody know where the DHCP server is? I'm looking for the DHCP server. Does anybody have it? For a broadcast address, the host portion is all ones. The host portion of the address becomes all ones. So a 95.255.255.255 will be a Class A broadcast address for that 95 network. 135.50.255.255 is a broadcast address for this Class B 135.50.00 network. This would be the broadcast address for that network. And for this Class C network, the 195.32.12.0 network, if we set this last octet to 255, that would be a way to get a message to everybody on that network. Again, why is this important? It's two reasons. One, this number is used to send a message to all nodes on the network. Number two, because of that, I can't actually assign it to anything. If I assign that number to like a printer, every time we tried to print to it, every time we go to print to the printer, that message would go to everybody in the entire network. Here's this file to print. Okay, that doesn't work. We can't assign that to anything. So those are numbers that we need to keep aware of. And eventually we're going to put in a chart to make sure they're in separate columns, that we don't use them. We don't use them to assign to router ports or servers or anything like that. So the host portion all zeros is a network number. The host portion all ones is a broadcast address. Now what's left in the middle is usable addresses. These are the addresses that would end up being 123 Main Street, Mechanicsburg, PA or 124 Main Street, Mechanicsburg, PA. Okay, so the host portion now is not all zeros and it's not all ones. So an address like 95.25.5.15, this isn't all zeros, this isn't all ones. That has to be a host ID. Has to be a host number, a usable address, if you will. 135.50.25.5 is a usable host IP. 195.32.12.5 is another usable host IP on this Class C network that's down here. Again, this is important because these are the numbers that I can actually assign to things like printers, desktops, servers, IP phones, access points, etc., 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 router ports, switch ports, etc. These are all numbers that I can assign to things in my network. Eventually, we are going to make a chart where the network IDs show up in one column, the broadcasts show up in another column, and then all the usable stuff shows up in the middle. And that way we know that middle column are the usable numbers we can assign to things on my network. Okay, so keep those numbers in mind. All right, subnetting. Subnetting itself, the fundamental idea is pretty simple. I'm going to take a group of numbers and break them into equal size pieces. Almost like taking a group of people and dividing them up into equal teams for blah game, whether it be tag or capture the flag or kickball or whatever. I break it into equal size teams, now we can play a game. Subnetting is the same concept. I'm going to take a large group of numbers and break it into equal size pieces, and those equal size pieces I could allocate to this campus, this building, this floor, this department. And if we were working with numbers in the 0 to 100 range, that kind of thing, this would be pretty easy. If I needed 4 subnets, I'd say, okay, 0 to 24, 25 to 49, 15 to 74, 75 to 100, bada bing, bada boom. I'm kind of wiping my hands now, going, mic drop, I'm done. 4 equal pieces of 25, there are my subnets. Easy peasy. That's all subnetting really is. I'm making equal size pieces that I can allocate to a floor, a building, a department kind of thing. The catch is, unfortunately, we're working with octets that go from 0 to 255. So to break them into equal size pieces, the numbers don't look so nice, and sometimes they don't work so nice. But I can still take 0 to 255 and break it into equal pieces. It's just the numbers look a little weird. 0 to 63, 64 to 127, 128 to 191, 192 to 255. This is 4 equal pieces of 64. It's just I'm not going to come up with them off the top of my head. I need some tools. I need some resources. I need some number knowledge with these 0 to 255 octets. I need some number knowledge to be able to do that. And luckily we have some tricks to do that, to help make that pretty easy for us. But that's all subnetting really is. I'm taking this 0 to 255 and I'm going to break it into equal pieces so that I can allocate equal pieces to this floor, this building, this department, this campus, etc. That's all we are doing. So take a pizza, cut it up in equal pieces. Take a pie, cut it up in equal pieces. That's what we are doing when we're subnetting. Now, there's a couple rules to do this. To do this, we're going to borrow bits from the host portion. So we have the network piece, we have the host piece. We are going to borrow a couple bits to create a subnet piece is what we're going to do. We're going to borrow a couple bits from the host portion to create a subnet piece. So if we expect the subnet mask to be 255.0.0.0, we're going to borrow a couple bits and create something like a 224 here, and that's going to give us a couple bits to create subnets with. If I have my subnet mask 255.0.0 or 255.255.0.0, I'm going to steal a couple bits from this octet here, maybe make a 240. Now I have a couple bits to make a subnet piece. If my subnet mask is 255.255.255.0, I'm going to steal a couple bits from this host piece out here. I might make it a 192. Now I have a subnet piece to create subnets with. That's what I'm going to do. We have a couple rules on how to do that. We're going to borrow bits from left to right. I'll show you that in a minute. And we need to make sure no matter what we do, we leave at least 2 bits behind. Again, I'll show you why that is. So let's look at the first one. Borrow left to right. Bits are always borrowed left to right from the host portion. So if I have a Class A network 125.0.0.0, here's the subnet mask 255.0.0.0, we are going to focus on the host portion, these 3 octets right here. Here's the 3 octets of host written out in binary. I'm going to start borrowing from these bits over here, and I will borrow left to right, just as I'm highlighting along here. So I can borrow right here, this is 240, I can take a couple bits here, and make that a subnet piece. And that I would reflect with my subnet mask 240. We'll get to that in a little bit. But it's really just this octet here written in decimal. That would be my subnet piece. I'm borrowing left to right. Let's look at a Class B. Class B is 255.255.0.0. Here's that host portion, all zeros. I'm going to start barring right here where my pointer is, and I'm going to start barring left to right slowly, and I will borrow as many bits as I need. So right here, I can borrow 3 bits right here from the host portion. 224 would be those 3 bits borrowed. Those would be the 3 bits borrowed to create subnets. If I have a class C, here's my subnet mask, 255.255.255.0. If I take the host portion here, there it is, all zeros, I'm going to start barring from here going right. I will start barring those bits, slowly going left to right. So out here, if I borrow the first 2 bits from that host portion, I could do a 192, and that would be my subnet piece. That would be my subnet piece. So no matter what, I'm going to borrow left to right from the host portion. Okay. When I'm done, I have to have 2 bits left in the host portion. No matter what I do, I got to leave 2 bits behind. So why is that? Okay, let's take a class C here. Here's our host octet right there. There's my 8 bits I have to work with. If I were to borrow all 6, which I'm allowed to do, I'm allowed to do that. I'm allowed to borrow 6, and I leave 2 behind. Well, let's focus on the 2 left behind. Let's focus on the 2 left behind. If I take those 2 bits that are left behind and I write all the possible combinations of 1s and 0s, we have 0, 0, 0, 1, 1, 0, 1, 1. That's all the combinations. Well, if I remember my rules, 0, 0 is not usable because all zeros in the host portion is a network number. If I look at 1, 1 and I remember my rule, all 1s in the host portion is broadcast address. This first number is not usable. This last number is not usable. That means there's only 2 usable addresses left behind. Well, with 2 usable addresses left behind, one of them is typically going to get assigned to the router, and the next one might get assigned to a switch, might get assigned to a PC. I literally would have 1 address left for a PC. So that's why they're saying, look, you have to at least leave 2 bits, because if you do not, I only have 2 numbers, and one will be the network and one will be the broadcast. So I have to leave at least 2 bits. And sometimes this is done, especially for WAN links. So that's why that 2 bits left behind rule. So with a class A, I have 24 bits I can work with. With a class B, I have 16 bits to work with. If I have a class C, I have 8 bits to work with. So with a class A, I can borrow up to 22 bits because I have to leave 2 behind. With a class B, I can borrow up to 14 bits, got to leave 2 behind. And with a class C, I can borrow up to 6 bits, I got to leave 2 behind. So I need to remember those rules. So borrowing left to right, and leaving 2 behind, those are rules I should remember.